Hey there, in this video we're going to talk about the extreme value theorem, finding absolute max and minimum values, and relative or local max and min. So this is part 2 of the video series on absolute max and min. So the extreme value theorem essentially says if f is a continuous function on a closed interval, then f attains an absolute maximum value and an absolute minimum value in that interval, that closed interval a, b. And those values occur at either the endpoint, a or b, or at the critical numbers of f that fall inside the interval, the open interval a, b. So absolute maximum value is essentially the highest point on the graph, and the absolute minimum value is the lowest point on the graph. So another way to say that is the absolute max is the highest value of the function on the closed interval a, b, and same for the absolute minimum. It will be the lowest value of the function on the closed interval a, b. Let's take a look at a graph real quick. So if we have this graph, you can see that when the derivative is 0, we have a relative max or a relative mean. So in this case, right, those are the peaks and valleys as I talked in the first video. And so I call them relative max, but they can also be referred to as local. So this could be a local max, or this could be a local min. So what the terminology refers to, that is at around a point, you are going from, for local min, around this critical number, you will be going from decreasing to increasing, right around that value. And for a local max, right around that critical number, you'll be going from increasing to decreasing. Now, what about, now notice that these I have them going on forever, but what if we truncate them? And I say, okay, this is stopping at a certain value. So say I stop this one there. So say then this is goes from just here, which is the value of a, to here, which will be, let's call that b. So now that we're on a closed interval, notice that we still have local mins and local max, but now we also have an absolute maximum. So this point appears higher than the local max. So this over here will be then a an absolute max. So the highest value of the function. And this, in this case, the way that I have it, notice that then this local minimum also becomes the absolute minimum because it is the lowest point on the graph. So the local min happens to also be the absolute min. So that's why the extreme value theorem says that when you're in a closed interval, your absolute max and your absolute min, so together, plural, we say the absolute extrema of the function, occur either at a critical number, so a local max or local min, or at an endpoint. So in this particular example that I kind of just drew, we have the absolute max occurs at the endpoint b, and the absolute min occurs at a critical number. But notice that the other endpoint a, nothing is happening. There is neither a local max or local min, neither an absolute max nor an absolute min. So, but b has the absolute max, and a critical number has the absolute min. So a value, a critical number, can be both the local min and the absolute min if it happens to be the lowest value on a graph. So like if you think about y equals x squared, for example, and you truncate it on a, say, -2 to 2, you have a local min at the vertex, but that will also be the absolute min. And so let me just draw y equals x squared since I'm talking about it. So just quickly looking at y equals x squared here, we can see that, as I was saying, if we truncate it at -2 to 2, just based on the graph, we can see that this is going to have at 0, we have a local minimum, but this is also the absolute min, right? The lowest value of the graph. And here you have a local max at 4. So if I truncate it on the interval -2 to 2, we have a absolute max, an absolute maximum of y equals 4, right? That is the y value, that is the maximum. And that absolute max occurs at 2 places. Occurs at x equals -2 and at x equals 2. So sometimes I get the question like, can you have 2 absolute maximums? It's like, no, you can only have one, because the absolute maximum is just a single y value, right? The absolute max, we're referring to the y values of the function, so there's only one. It occurs at 2 places. So an absolute maximum, yes, an absolute maximum can occur in 2 places, but it should only be one y value, right? The absolute maximum here is y equals 4. It occurs at -2 and 2. So you cannot have 2 absolute maximums, but the one absolute maximum can occur at multiple places. So I hope that that makes sense. If you think of sine x and cosine x also, for example, right, their absolute maximum y value is 1, but it occurs infinitely many times. But there's only the one y value of 1 that is the maximum. All right, so let's try an example. All right, so find the absolute extrema of this function on the closed interval 0, 2. Now let's go back to this statement of the extreme value theorem. So the extreme value theorem says if f is a continuous function in a closed interval, then f attains an absolute maximum value and an absolute minimum value in that closed interval. And then those values occur either at the endpoints or at the critical numbers. So let's see if the theorem applies. Is f of x continuous on this closed interval? So are there any discontinuities here? This has a chance of not being continuous if the denominator is 0, but notice that that one is x squared plus 1, so the denominator is never 0, so we don't have any points of discontinuity. So we can say f of x is continuous on the interval 0, 2. And so then, because it is continuous, then by the extreme value theorem, f of x has an absolute max and min. So f of x, I'm going to say, has absolute extrema. So what that means, when you see absolute extrema, that means that it has absolute max and absolute min. So absolute extrema is the kind of like the plural. Instead of saying every time absolute max and absolute min, we just say absolute extrema. So that means that they occur either at the endpoints or at a critical number. So when we check for the y values, right, so I'm going to check my endpoints, which my endpoints are 0 and 2, and we're going to check our function to see which one has the highest y value, right? If we don't have the graph, we are going to plug in the points and see which one has the highest y value, because that will be the absolute max, and which one has the lowest y value, that will be the absolute min. But these are the endpoints. We need to see if we have any critical numbers to test. So how do I check if we have critical numbers? Find the derivative, set it equal to 0, and see if the derivative is ever 0 or undefined, because that's where critical numbers come from. So let's find f prime. So let's take the derivative. So here I have a function with a numerator and a denominator, so I'm going to use the quotient rule. So f prime of x will be the bottom, so x squared plus 1, times the derivative of the top, so times 1, minus the top, x, times the derivative of the bottom, the derivative of x squared plus 1, which is 2x all over the bottom square. So f prime of x, simplify this, x squared plus 1 minus 2x squared over x squared plus 1 quantity square. And can I continue to simplify? Well, I should, because I need to solve this. I need to set it equal to 0 and solve. So I'm going to have 1 minus, right, x squared minus 2x squared is minus 1x squared over x squared plus 1 squared. Now here, let's be careful. Notice that that is 1 minus x squared, which is not the same as x squared plus 1. Even if I rearrange it, this will be negative x squared plus 1 over x squared plus 1 squared. These are not the same, right? That's a negative 1 times x squared, and this is just an x squared, so I can't cancel anything. So that is my derivative. So now we set it equal to 0 and solve for x. So I'm going to have negative x squared plus 1 over x squared plus 1 squared equals 0. And numerator is, or sorry, a fraction is 0 when the numerator is 0, and a fraction is undefined when the denominator is 0. We already know that x squared plus 1 is never 0, so this is never going to be, the derivative is never going to be undefined. So let's look at where the derivative is 0. So f prime of x equals 0 when negative x squared plus 1 is 0, right, when the numerator is 0. This gives me 1 equals x squared, so x is plus or minus 1. Don't forget to do the plus or minus when you take the square root. That's why sometimes I prefer factoring. So if I do it by factoring instead, set it equal, or multiply everything by a negative 1, so I'll have x squared minus 1 equals 0. So this is x plus 1, x minus 1, difference of squares, and then it's easier to see that, oh, x is negative 1 or x equals 1. So I get my two answers. I prefer factoring than taking the square root of both sides, just because sometimes I forget too about the plus or minus, but factoring doesn't allow for that little mistake to happen. All right, so what are we doing? So what, now that you found the derivative in critical numbers, what? Okay, so we're looking at find the absolute extrema on the interval 0, 2. So let's look at our critical numbers. We have critical numbers of negative 1 or 1, but x equals positive 1 is the only one that is on the lies inside our interval. So x equals 1 is in 0, 2, so we'll only need to test that one, right? Negative 1 is not in that interval, so we don't have to do that. And looking at your derivative again, just I want to mention again that the reason I ignored the denominator is because it's never 0. If I had something in here that I could solve for x when the denominator is 0, those will also be critical numbers. It will be where the derivative is undefined. All right, so let's go back over here. And now that I know that I have critical numbers, sometimes you may get critical numbers, but they're not in the interval, so then we don't have to test them. But here I do have one critical number of 1. Why am I testing that? The extreme value theorem says, right, let's go back to that if a function is continuous in a closed interval, then it attains an absolute maximum and an absolute minimum value in that interval. And these values occur either at the endpoints, so I have to check 0 and 2, or at the critical numbers. So I need to check my critical numbers as well. So that's why I'm checking the endpoints and the critical number that falls inside that interval. So let's plug in now and compare the y values. Absolute maximum is the highest y value, absolute minimum is the smallest y value. So when you plug in 0, you're going to have here 0 over 0 squared plus 1, which is 0. Plug in 2 over 2 squared plus 1, which is what, 2/5. And plug in 1, you're going to have 1 over 1 squared plus 1, which is 1/2. So which one is the highest one? So I can see that the lowest one is going to be 0. So that is the absolute min. And then 2/5 and 1/2, well, 2/5 was that 0.4 and 1/2 is 0.5, so this is the highest one. So then this is the absolute max. And so notice that the absolute max occurs at a critical number while the absolute minimum occurs at an endpoint. So that's why it's really important to check both your endpoints and any critical numbers. So let me write out our absolute max and absolute min properly. So we can say f of x equals x over x squared plus 1 has an absolute maximum of y equals 1/2 when x equals 1, so that's when it occurs, and it has an absolute min of y equals 0 when x equals 0. So watch out for that in homework. Sometimes I get emails saying like I got marked wrong, and it'll be because you might be saying has an absolute max of x equals 1, and it's like it occurs at x equals 1, but actually the absolute maximum value is y equals 1/2. So be careful about what is asking you. Is it asking you what is the absolute maximum, what is the absolute minimum, or where do they happen, at what x value? So just pay attention to the wording of what you're being asked to do. So let's try one more example. Okay, we'll try to go through this example somewhat fast. Find the absolute extrema of this function on the interval 0, 4. So absolute extrema, we have a function on a closed interval, so we need to check, is it continuous on that interval? Well, x by itself, that's a line, that's continuous. Inverse tangent, is inverse tangent continuous on that interval? Yes. So if you think about the graph of inverse tangent, I always kind of think of it as it looks like the cubic function but sideways. You have asymptotes at pi over 2 and negative pi over 2. Horizontal asymptotes, I mean. So this is your inverse tangent, and then y equals x is just a line through the origin. So there's our y equals x, and this is our y equals inverse tangent of x. So when you have a constant, it's still going to be continuous. So you have the difference of two continuous functions. So back from chapter 2 when we went over continuity, the sum or difference of continuous functions is continuous. So we can say f of x is the difference of continuous functions, and therefore is continuous on the closed interval. And so since we have a closed interval, by the extreme value theorem, the function will attain its absolute max and its absolute min on that interval. So either at the endpoints or at the critical numbers. So let's find the critical numbers first so that we can then check everything together. So find critical numbers. So how do you find critical numbers? These are when f prime is 0 or when f prime is undefined. So let's find f prime. So our function is f of x equals x minus 2 inverse tangent of x. So f prime, what is the derivative of this? So you'll have the derivative of x is 1 minus 2 times the derivative of inverse tangent, which is 1 over 1 plus x squared, or x squared plus 1, however you want to think of it. And then simplify this. So f prime is 1 minus 2 over, I am going to write x squared plus 1 just to write it in descending order. And you want to set that equal to 0 and solve for x. So we can either get a common denominator here, or you could move the 2 over x squared plus 1 to the other side and do cross multiplying. I'm just going to get a common denominator. So this is 1 over 1. So my common denominator is x squared plus 1. So multiply top and bottom by what you want the common denominator to be. So my f prime, then the derivative becomes x squared plus 1 minus 2 over, now they're going to have the common denominator of x squared plus 1, and simplify that. So I'm going to have x squared minus 1 in the numerator over x squared plus 1. Again, be careful, don't cancel that. That is not algebraically correct. Now set that equal to 0. So the derivative is 0 when, since we have a fraction again here, when the numerator is 0. So f prime of 0 of x, is 0 when the numerator is 0. So that means when x equals plus or minus 1, so kind of similar as before. And then we are on what interval? Always check to see if your critical numbers are in your interval. So the interval 0, 4. So again, only 1 is in that interval. So we're going to say x equals 1 is in the interval 0, 4. So we're going to take that one. And f prime of x is undefined when the denominator is 0. So when x squared plus 1 is 0, but this never happens, right? If you set that and try to solve for x, you can't. It's an imaginary number, so therefore it's not undefined, so we don't get any critical numbers for that. So now we're ready to test our function for absolute, max, and min. So we're going to test our endpoints, so 0 and 4. And we have a critical number of 1, so we're going to test that as well. So 1 and 4. So just to make it clear here, 0 was an endpoint. So that's why we're testing that. 1 is a critical number that fell inside our interval, so that's why we're testing that. And then we're testing 4 because it is also an endpoint. And so these are our x's, and we're testing them into our function, right? Y equals x minus 2 inverse tangent of x. And so plug in when x is 0, you're going to have your y is equal to 0 minus 2 inverse tangent of 0, which is 0. So we just get 0 for that. And when x is 1, you're going to have x, so 1 minus 2 inverse tangent of 1, which is 1 minus 2 times inverse tangent of 1 is pi over 4. So that's 1 minus pi over 2, right? 2 and 4 reduce, so getting a common denominator here, what is that? 2 minus pi, the whole thing over 2. And then when x is 4, y is going to be 4 minus 2 times the inverse tangent of 4. And this is a little bit harder to see, but we can kind of, based on inverse tangent, take a look at, we're doing inverse tangent of 0, 0, inverse tangent of 1 is pi over 4 is what we got. Inverse tangent of 4, notice that it keeps getting, it's increasing, right? It's getting higher, so it's probably going to be more. But you can put it in your calculator and see what you get. Just make sure that we are in radians when we evaluate things like that. Any trig stuff in our calculators, make sure that you're in radian mode. Alright, so once I put this in my calculator while being on radian mode, I got 1.348. So that appears to be the max, unless this is bigger, but I don't think that this is, right? 2 pi, the approximation is 3.14, so this is likely a negative number. And when you do that on your calculator, I got negative 0.571. All right, so then we compare the y values. Which one is the lowest? The lowest will be at the critical number. So the lowest y value is 0.571 and the highest y value is 1.348. So the absolute max is y equals 1.348 and it occurs at the endpoint when x equals 4. The absolute min is the lowest y value, which is negative 0.571. Y equals, and it occurs at the critical number x equals 1. So we can write that out a little more formally. So here we go. Absolute maximum is y equals 1.348 at x equals 4, and the absolute minimum is y equals negative 0.571 at x equals 1. I put them in decimals. I would prefer probably, I guess, to leave them in their standard form, like 2 minus pi over 2 and 4 minus 2 inverse tangent of 4. But I know in the homework sometimes you're asked to put it in decimals. Pay attention to how many decimals you're supposed to round to. That way you do not get marked wrong. Sometimes it says to round to 4 decimal places, so if I put these answers it will be marked wrong because it's not to 4 decimal places. Even though the answers are correct, I just need to go to that extra decimal place. Likewise, if you're told round to 2 decimal places and I put these answers, I will probably be marked wrong. So just pay attention to how many decimal places are required when you enter your answers. All right, let me know if you have any questions.